smart? Just raise your hand. Some of you don't want to be smart. I like that. Well, as the story goes, there was a certain man who also wanted to be smart. He, along with his good friend who wanted to have a heart, as well as his other good friend who wanted what? Courage, spent a little journey, and in order for the man to become smart, he needed to know this Pythagorean theorem. So I brought this little clip just to show you what this is all about here. In order for you to be smart, apparently one must know this here. So here we go. Let's do a little musical interlude here. Little lights. Do we have some lights here just for I thought we would spend the whole class period watching Metro Goldwyn Mayer and the Wizard of Oz. Kind of a scary story, so if you get afraid, just close your eyes. What? Yeah, it is. What about the heart?
I'm scared of why anybody can have a brain. That's a very mediocre commodity. Every juice and animal creature that crawls on the earth or drinks those slimy seeds has a brain. Back where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Collegiatum E Pluribus Unum, I hereby confer upon you the honorary degree of Ph.D.
Now, pay attention to what Mr. Scarecrow says.
Ph.D. Doctor of Theology. The sum of the square roots of any two sides when I plot these triangles equal to the square root of the remaining side.
Now, unfortunately, that is not right. Did we do this last year?
No.
He said the sum of the square roots of two sides of an isosceles triangle
Triangle is equal to the square root of the remaining side.
is equal to the square root of the remaining side.
Oh, John.
I hate to break it to you, Mr. Scarecrow, but you're wrong.
No brain.
Alright, lights please. When in actuality, the Pythagorean theorem doesn't say any two sides of an isosceles triangle, it is of a right triangle. And you've seen this before. You'll hear people say this. The Pythagorean theorem really is this. A squared plus B squared equals C squared. And written out in words, what that says is the sum of the squares of the two legs of a right triangle equals the square of the hypotenuse. And that's probably why he didn't say it the right way, because it's which is the third side. I'll let you write that, and then we'll talk just briefly about that. Because you have to know a couple things in order to be able to do this. Did we do this last year? I thought we did this last year. Maybe not. Okay. In order to understand this, or be able to do this, okay, you must know this. Here is my right triangle. Okay? In a right triangle, the longest side is called the hypotenuse. It's the longest side, and it's also the side that's directly across from the right angle. Wherever the right angle is, you shoot across. That is the hypotenuse. The other two sides are called the legs. And it doesn't really matter which one is which. So if I'm putting letters in that stand for these letters that are in the Pythagorean theorem, it could look like this. A, B, C. The hypotenuse is always C. These two can, A and B can be flipped around. I could have called this A. These are the legs. They can go in any order because addition is the commutative property or whatever there. Okay. Now what that says is this. If I have a right triangle, and I know that this is 3 inches, and I know that this is 4 inches, I can figure out what this hypotenuse side is by plugging it into this formula. And it looks a little like this. You get, again, I'll write the formula down, a squared plus b squared equals c squared. And you have to fill in the blanks with the numbers, people. You can't, this is not something you can do in your head. 3 squared plus 4 squared equals c squared. What is 3 times 3? 9. 4 times 4? 16. And 9 plus 16 is 25. Now that equals c squared. Okay? In other words, c squared is c times c. If c squared equals 25, you're asking yourself, c times c equals 25. What number times itself gives you 25? Alexa? 5. This side has to be 5. Okay, and that's the way it works. If you work in construction later on in your life, you will use that to the nth degree. You'll use that every day of your life. Because it's a great way to make walls square. You know, because you can't, how do you know if something's a perfect right angle? You know, they make squares, but squares are only so big. You can't get a life-size square. Well, if you want to know if something is square, if I want to know if this corner is square, I can take a ruler, measure out 3 feet this way, measure out 4 feet this way, and then run my ruler between those 2 points on the sides, and it has to be 5 feet. If it's not square. It's not a right angle. Now, here's something that throws a little wrench into the situation. What if my triangle is a 1 by 3 triangle, and I plug that into the Pythagorean theorem? A squared plus b squared equals c squared. Well, I get 1 squared plus 3 squared equals c squared. 1 times 1 is 1. 3 times 3 is 9. 1 plus 9 is 10. And 10 equals c squared. So, if c squared equals 10, what does c equal? Not 5, because 5 times 5 is 25. It would be a huge decimal number, Michael. Okay. Unfortunately, children, in the world of math, there are not going to be very many Pythagorean ones that work out nicely like the first one we did. Most of them, in the real world, will do this and not work out. Now, this isn't quite the answer, but it's close. Okay, if you remember me talking about square roots were like the opposite of squares, or roots are the opposite of squares. If you see this, and I said this before, this is c times c equals 10. What number times itself gives you 10? That's the same thing as saying what is the square root of 10. Okay, just like in this one we just did. When I asked you this 25, what is the square root of 25? 5, that was our answer. Well, when they don't work out, you just leave it as the square root of 10. Let me try to build this in here. What if I had c squared equals 8? What is my answer? C equals the square root of 8. What if I end up with c squared equals 32? C is going to equal the Square root of 32. What if I get c equals 5? C squared equals 5. C is going to equal square root of 5. Anytime you get a square equal to a number, that means it's equal to that square root. Something like that. And that's what's going to happen most of the time. Okay. Now, well, let me check and see if they give us stuff in that doesn't. Oh yeah. Oh yeah. Here's one from the book. Now notice all the examples I've done so far, you are just missing the hypotenuse. I don't know. What happens if we're missing a leg? Anybody in here missing a leg? No, it looks like you all have legs for the most part. What if it is? Well, there's one in the book that I don't know if I want to use. Well, let's do this. This is 24 and this is 26, and I don't know what this is. I'm scared to even try this. If I get a squared plus b squared equals c squared, I don't know what a is, so it's still a squared. I do know that b is 24, right? And I do know that c is 26 squared. This is some heavy-duty math here. What is 24 squared? Does anybody know? How about 576? Everybody good with that? What is 26 squared? Actually, nobody's jumping ahead on me here. 676. 676?
Yes.
Is it?
Yes.
Is it really?
Yeah, that's what I got.
Any idea how I'd figure out what the letter a squared is? What number plus 576 gives me 676? 100. So a squared has to equal 100. So a has to equal the square root of 100, and there is a square root of 100, which is, this side has to be 10. Isn't that sweet?
Is that why some part has so many, or less problems than
Kind of. Now, here's the deal, people. You will see, and you've probably always wondered why this little sheet is up here. Okay, 90% of right triangles don't work out nicely, but the ones that do work out nicely are called the Pythagorean triples. No, you can write this down, whatever. Triples. Okay, and like I said, in construction, you'll hear guys talk about a 3, 4, 5 triangle. What they're talking about is a Pythagorean triple that makes a right angle. All of these right here, a 3, 4, 5 triangle means that you can have a triangle that is 3, 5, 4, 5, 5. Or this one here, a 5, 12, 13 means that you can have a triangle that has 5 for one leg, 12 for the other leg, and 13 for this leg. Those are ones that work out perfectly. If you were to put them in the Pythagorean theorem, they work out nicely. You know, there's some goofy ones here like 16, 63, 65. Ones you won't hear very often, 9, 40, 41. I'll actually going to give you this piece of paper so that you can see it. Okay? It'll make your life a little bit easier. However, okay, these are not the only ones. Okay? The reason they're not the only ones is because these are just the base Pythagorean triple triangles. With 3, 4, 5, in this particular ratio, there are bazillions of triangles that I can make with that. In other words, this. Speaking of the scarecrow,
What are we doing?
Pythagorean theorem.
Pythagorean
Yeah.
triangles?
Yes,
Yes.
That right there. Pythagorean triples actually at this point.
Okay, what's that mean?
Yeah, I didn't think that. See, you've already eclipsed the level of the most educated of our music directors.
The scarecrow. Oh, Wizard of Oz, that scarecrow.
Slimy seeds and the rain.
Why would I be the scarecrow? I'm just curious.
What just seemed to happen there? Do you have an announcement for these kids?
I don't have an announcement. Actually, I have a math problem that I need help with.
Oh, can the 7th graders do it?
I don't know. Do they know circumference?
Yes, I do. Yeah, I do. See,
Is
you're
the
all
question-
the
is
C.
the question of pi times diameter?
Pi
What?
times diameter. Pi times right.
So can you tell me the circumference of this?
Well, if we can measure the diameter, if we can get the diameter close enough,
What is that?
it's his ring.
It's not
There's
my
a
ring,
ruler.
it's our ring. I need to know what ring size this is.
But what a ring size in though?
What?
Ring sizes are like a size 7 or something, isn't it? They must.
Correct, but however many millimeters.
It's
equals-
millimeters?
Well, I can do millimeters or inches.
You have the chart,
Doesn't that
yeah, it's on mine.
so you just need to measure across the diameter of that. You guys got your ruler right
Who's
here.
got a ruler?
Kelsey's got a ruler right in her hand, right there.
Alright, you tell me how many.
Practical applications of mathematics. Can you get a straight up measurement? You need the diameter.
You're wanting to do inside.
Yep.
Inside to inside.
And you need to get the biggest possible measurement you can get. So keep moving your ruler until it gets the biggest number you can get inside.
Do you wanna, or do I, how do I, this is that? Not really.
What? Is it exactly 20 millimeters? And the thing with rings is they're not always exactly.
No,
Well, you're not quite. I would say it is. How close do they actually end up being? I would say it's awful close to 19 millimeters.
alright,
Which means if you're taking 3.14 times 19 millimeters, what would be a quicker way to do that, Peter? Multiply it by 20. 6280. 628. Take away 19.
59.66 millimeters.
Did you? Did you do it?
Yeah, 59.66.
whoa, time out, who just did that?
That'll be Nick.
He's a smart man. He does 8.
I'm gonna make sure.
I did it right
You like his father?
Yes, I did.
Oh. Which is 59.66. I don't know if it's in, it must be millimeters. It doesn't do it in centimeters, does it? If you want that in inches, you can do that by
59?
millimeters.
This is a size 9 ring then?
Is that what it says?
I am not, but someone in the youth group is going to be.
So it's, what's it says, size 9? Because it says size 9 is what?
Here's the ring chart.
Has a circumference, and it's in millimeters.
Because otherwise, that's all. No
Oh,
rings.
no, it says diameter in millimeters. We didn't need the circumference, it asked for the diameter.
What was the diameter? Oh, that I didn't see this.
Oh, diameter in millimeters.
So it'd be 9, which you came up with 59, which because the other chart I found only said this circumference, it didn't tell me the diameter. So this is a size 9. What size are you? I did not think I was a size 10 or 11. But I guess it must be.
See, there you go, kids, practical applications.
No, every couple of years, what we do at the high school level is we do a mock wedding where we do a relationship series. And then 2 people, and male, female obviously,